The access gateway comprises of two distinct components, the Apache reverse proxy and the embedded service provider, the ESP. The proxy is responsible for taking HTTP requests from a user agent, forwarding them onto a backend web server, taking the response from the web server and passing it back to the browser or the user agent. The ESP is responsible for authenticating the user and retrieving attributes that may be required by policies enabled on the reverse proxy. We're going to look at how to enable the logging options on both the Apache reverse proxy as well as the embedded service provider, and we look at the log files they create. For the Apache reverse proxy, you can go into the AG cluster, select the advanced options, and I've highlighted 6 fields in here. The first one here is debug headers. With debug headers equal to on, every request into the reverse proxy will get a response back with an XMAG header, and that XMAG header is going to contain some useful information about how that request was handled by that reverse proxy. The log level defines the level of logging enabled on Apache. By default, it's set to minimal. For troubleshooting issues, you really want to set it to info. And we'll have a look at an example in a minute when it's set to info. For SSL related issues, you want to set it to debug. The only difference between debug and info is that we log SSL transactions in there as well. So if you're accelerating a secure backend web server or you have SSL enabled on the reverse proxy, you may want to set it to debug if you suspect that you're having SSL related issues. The dump headers, dump response headers, dump headers facility and response headers facilities are all specific to logging of the HTTP requests. So it's something akin to the HTTP header file that you have on plugins via the browser. The files themselves are located in the following directory: varlog novel apache 2. So when those advanced options are set, we're going to get this file is going to be determined by the log level settings, and this file is going to get determined by the HTTP header settings. So I'm going to reset the logs temporarily. And I'm going to go into my browser and I'm going to access a protected resource. Okay, it's a protected resource. It requires me to authenticate, so I'm just going to log in as myself if I could type. And we'll look at a couple of things associated with that request. So down here I have HTTP headers on the workstation. So the first thing I'm going to identify here is the XMAG header I spoke about there. So the XMAG header has a couple of key fields in there. I've highlighted them there. The 88F6, that is the ID associated with the access gateway. So if you have multiple access gateways in a cluster, the ID represented in the XMAG header will reference the AG within the cluster that handled that request. The second field is the last 8 bytes of the session cookie, the AG session cookie. And the third one, very importantly, is the event ID. So by looking at the third one here, 877 in our case, we can go directly to log file. For example, I'm going to look at the HTTP header log file, which is a log of the HTTP requests. And I'm going to look at 877. And it'll be the second one. Here we go, 877. So in here, you can see the request coming in. So the 877, this is C request. This is the request from the browser to the proxy. This is what the request looks like. There is the source and destination IP addresses, ports, and the headers. Then we go on to the corresponding request over to the backend web server. So 87, this is from AG to web server. Now you'll notice in here, there'll be a change. We inject some additional headers like X forwarded, for X forwarded, host, etc. If you have identity injection, you're going to inject the identity injection header in there. Then you have the response from the web server to the proxy, and finally the corresponding request from the proxy to the backend client. We can also take that information, and if we look at the error log file, we can get a little bit more detail on the actual request itself. So I'm going to look for the event ID 877, and in here you'll actually see the processing of the request. So in here, there's the GET request coming in. It's checking to see whether I have a cookie. It's a restricted URL, i.e. it's protected. It requires me to authenticate. It checks to see what protected resource I'm tying into. So that's the name of the protected resource that I have. This is the contract it's protected by. And I can navigate down through this 877. In fact, I'll go down here, and you see these entries here. The request is being sent from the AG over to the backend web server. I'm sending the request, and then I get my response back. So very, very useful for troubleshooting or finding connectivity related issues in the Access Gateway. The second setting, as far as troubleshooting is concerned, is related to the ESP. Now, for the ESP, you have to go into the IDP cluster configuration, logging, and even though it's on the IDP, it actually applies to the ESP as well. So you're going to go in here, enable file logging, echo to console, and the key ones for policies and authentication are typically Liberty, Application, Web Services Consumer, and Web Services Provider. If you enable them and set them to debug, when you go in and have issues during authentication or policy evaluation, you can go in and access the OPT Novell Nam mag log file here. So if you have issues that are specific to authentication or policy evaluation, you can actually go and navigate through this file here and get some information regarding as to why the problem occurred.